Hello and welcome to my audio movement project. The idea behind this project was to learn about some of the interesting ways to move and randomly trigger sounds in a game. The project was inspired by a talk at the Game Audio Symposium in 2025 given by the team working on Still Wakes the Deep, and the talk was about some of their interesting audio triggering systems. So starting off, I had a look into splines. So these are a cool way of creating your own track for something to move along, and in game audio I have mostly used it myself in this first scenario. For some sounds like a stream, to have a directional sound for the rushing water, instead of adding multiple sound cues into the world along that stream, you could just have one sound and have that attached to a spline. So with some blueprints, that sound is being updated to move along that spline depending on the position of the player. In this example, I have just a sphere for reference to where the sound could be. But as you can see, the sound can move along the spline pretty well. However, one issue is that it cannot follow the shape that I have created. So when starting this project, I knew I wanted to be able to randomly move a sound a distance and wondered if using a spline in a similar way could be an interesting solution to this. So I created a blueprint system that at the press of a button would move a sound according to the direction of the spline. In this blueprint specifically, it takes the last spline point of the spline, calculates which direction the last spline point is from the start of it, and then moves the ball in that direction by a random amount. Then, using the same blueprint node as that initial spline example that I just showed, the ball is then snapped in position to the closest point of the spline. So let's see that in action. So if I press this button, we hear it move, it follows the spline. I press it again, it moves only a little bit, and now it starts getting stuck. So it is moving, but it's really not moving the way I want it to. So as you can see, this system has trouble following the shape of the spline to the end and has a tendency to get stuck. So I had to rethink my idea of using a spline. In this second example, I decided to make use of another common way splines are used, which is for AI movement. By creating a timeline, the audio sphere can now move along the spline over a set speed or amount of time. I can then use that amount of time as a variable to feed some random float ranges into a delay and play the sound at random positions and times along the spline. So let's give that one a go. Cool. So it's randomly selecting when to play a sound and an amount of sounds to play, and it actually is following the shape. So is this system useful? That's up for debate, but at least now the sound follows the shape of the spline, which I can now make into any shape I want. In this scenario that I came up with, these are some pipes, and inside there is a rat which can move along a spline. And the blueprint then plays the sound of the rats going around at different positions along it. Let's give it a listen. There you go, there's that example. Strange one, I know, but it's something I could come up with. If you have any other ideas for something that you could use a spline like this for, let me know. Otherwise, let's move on. So after looking into the use of splines, I also wanted to be able to move a sound around a space randomly without being tied to a spline. So to do that, I created this sound ball blueprint, which has a system which is basically to move the sound ball location to another one and randomize multiple elements such as the amount of times that it moves, the time between the movements, and the distance by which it moves. That was the original design, but then I realized that to make it a little more similar to the Still Wakes the Deep system, I wanted to make it move towards a certain direction. In the blueprint for the sound ball, we can see that direction system where it takes the first movement, adds it to an array, and then we calculate the direction it moved the most in first, and then adds a value to that direction at each subsequent movement. Let's have a look at how that moves in the game. Cool, there you go. Bit of randomized movement there. So the next step from there was to have the ball be within a space, but also keep it contained within that space. So to do so, I came up with this ball in a box system where the ball can move randomly around, but as soon as it hits the wall, it sort of bounces off and back into the box. In the blueprints here, we can see that using an end overlap for the container box, we can use that to move the ball halfway between its outside position and the starting point of the ball, in a way sort of mimicking it moving back inside the box. Let's have a look at this one. Cool, so you sort of saw it there. It goes outside of the box a little bit to give us that overlap trigger, and then sets back inside it. Cool, so for the examples, I of course wanted to somewhat recreate what is shown in the Still Wakes the Deep talk that I saw. So I created this example, which is basically supposed to be a big ship, and there is something inside there creaking and moving around. So in the blueprints for this one is where I wanted to add an extra function that calculates the largest area axis of the container and then tries to move the sound along it back and forth. Let's have a listen and look at this one. So in this final example here, I thought, well, what if there is a person or creature inside a box that keeps trying to get out? I modified the blueprints a little bit for the pattern and the randomness. But let's have a look at this example that I call Stuck. Cool, so it's not the most advanced system, but it's something interesting. So that's all of my examples here in Unreal Engine. As a test though, I wasn't quite done with the project because I wanted to be able to see if I could recreate the splines and these ball movement examples and blueprints in Godot. Let's just jump over there real quick. Welcome to the Godot project. This is basically the same, just without the examples. So we've got the spline, we've got the sound ball, and then we've got the ball in the box. Let me just show you them working first, and then I'll go into how they work in Godot. So first of all, here is the spline. Here is the sound ball. And here is the ball in a box. So the spline is similar to the one in Unreal Engine. There's a couple little differences though. I can't get the length of the spline that you can do in Unreal Engine with the blueprints. What you can do instead with the spline, it's actually called a path 3D, and then an object that is on that is the path follow 3D. If I set the progress ratio to 1, then we see that the progress is at the end, and that gives us this figure. I could technically at the beginning set this value to be 1 and save this as a value, and then whenever the progress number reaches a number between 0 and this number, to then play the sound potentially, but I didn't have that set up in this example. So now instead I just input whatever the length is myself. Of course I'd rather have this be automatically calculated, but that's just how it is at the moment. This is the process function, which is similar to the event tick function in Unreal. What we would do is we test that the progress value of the ball, of the path follow 3D or the ball, is the same as the two random figures that I've gotten between 0 and the full length of the spline, and then whenever it is, it would send out a bunch of values. It would send out a bunch of triggers, and the issue with that is that it would trigger a bunch of times. It wouldn't sound very good. So instead I opted to go for a timer system, where we can play a timer. We can set the length of this timer to be something random, and then when the timer finishes on timer timeout, we then play the sound. This is fine, except if I wanted to add more sounds to this, I'd have to make more timers and add them on. The other way of doing that would be to add them to the node tree, and then once they're added, set the value to, again, a random value, which is, I believe, is possible, but I haven't set up in this system, so as it stands it's not perfect, but it will run. So yeah, that's the spline script. So this is the sound ball in Godot. Basically we've got a few extra things added on here, a few extra controls. The ball behaves right now with these settings, it'll just sort of bounce around randomly, no sort of direction or anything, just moves around. And then similar to the one in Unreal Engine, I created a system to make it go towards a general direction. So if I turn the general direction on now, and then I press play and we test that, see, it started going up. Basically it calculated that the first movement went up more than any direction, and so every consequent movement continued going upwards. Still slightly random, but it moved. Let's try that again just for another example. Oh, there we go, it's going this way, and off it goes. Cool. I've also got some other things, so I can change the amount of movements. I can change the distance that it moves, or the randomness between the length of its movement. Over in the timing section, we can change between the time being random. So as it's set off here, we have time between
being 0.3, so it'll wait 0.3 seconds to make each movement. If the time is random, it will choose a value between this number here, random time low, random time high, and it'll sort of make it a little more janky, let's say. Then we've got a couple extra things where we can change the speed of it throughout runtime. So we can have it get faster by decreasing these values, or we can have it get slower by increasing these values on each turn. It's just something extra I wanted to add to see if it was possible, and it is. Let's have a quick look in the script there. So I just want to show off the way I set up and worked through the system that is making the ball move in a certain direction. So on the first turn, on the first movement of the ball, basically we calculate the difference between the initial location and the new location. We separate those into X, Y, and Z. We make sure those are absolute values so that if they're minuses, we can still use them. And then we add that to an array. So we can then measure which number in the array is largest. If that number in the array is equal to 0, then that means that the X location is the largest, so we need to add to that. If the number is less than 0, then it needs to be a minus number. If it's positive, it needs to be a plus number. The same happens with the X, with the Y and the Z's as well. And then we add those values in another function to the position. Now taking a look at the ball in a box in Godot, it is obviously slightly different. So I did have it set up originally where we have a box that the ball is within, and then it would measure, it would tell me whether the ball is in or outside of that box using an area 3D, which is how it's supposed to work. But I believe because I am just setting the position of the ball to be something different, that the actual triggering of that doesn't work. So instead, what I've had to do is come up with a sort of roundabout way to show the ball within a box. I can set the size of the box to be whatever I want it to be. Once the box is set to the size of this value, on each movement we make sure that the new X, Y, and Z values are less than that container size. If they are any larger by any point, that gives us a trigger to basically say we can bounce off the walls and sort of head back inwards in a similar way to it is set up in Unreal Engine. But there you go. Cool. Hope you enjoyed it. If you've got any questions, just comment them or get in contact with me. Thanks for watching. See ya.